Hi, so the second video of section 3.1 is about learning objective 3.1.2, which is to evaluate the accuracy and precision of a measurement. And those two words are often interchanged in everyday language, but in science they mean really different things. So we want to be very specific when we use the word accuracy and precision. So you look at, there's four kind of bullseyes, targets on this page. And the first one in the upper left-hand corner is both high accuracy and high precision. Then the one right next to it is low accuracy but high precision. And think about what is common between those two. Because what is common between those two is the definition of precise. So see if you can figure that out, comparing these two. And then take a second and compare these two. What is similar and what is different about these two pictures? Because what is similar is accuracy, and what is precision is what's different. So think about that. And once you think you might have an answer to what is accuracy and what's precision and what's the difference, see if your prediction for the definitions matches up with that fourth target. Does your definition that you've made up in your head match with that fourth target being low accuracy and low precision? So if you want to take a second to pause the video and write down your predictions, you can write down your predictions. And then we'll continue on with the actual definitions. So the actual definition of accuracy is the closeness of a measurement to the actual or true value of that measurement. So let's see here. The closeness of a measurement So accuracy, the closeness of a measurement to the true value or actual value of that measurement. And the way that I remember this is thinking about the word accuracy begins with the letter A, and actual value begins with the letter A. So accuracy is how close you got to the right answer. You can only measure the accuracy if there is a right answer. So if we're doing a lab and I'm asking you to find the density of lead, there's a real answer to that. So we can measure the accuracy of that. But some things, what is the best laundry detergent? There's no right answer to that, because what is best? So a lot of times you can't actually measure the accuracy of a measurement. In those cases, what you can often measure or describe is the precision. So the precision is how close a series of measurements come to each other. Right? How close a series of measurements come to each other. And the way that I remember this is think of the sound in the middle of the word precision, right? And that helps me to remember that it must be a series of measurements. So if I measure the density of lead once, and then I can't even talk about its precision, because in order to talk about the precision, you need a series of measurements. So now take a look back at the bullseyes. Do those confirm those definitions that we just wrote down? Accuracy is how close you came to the bullseye. So look at here. These are very accurate. They came close to the bullseye. You may look at these and say, well, do they come close to the bullseye? But they're all relatively close. And if you were to take the average of those, it would probably be right in the middle. And then think about precision, how close a series of measurements come to each other. Right? Look at how close those different arrows or individual shots are. They're really close to each other. Same thing here. They're also really close to each other. So that's what precision is. In both of the pictures on the bottom where the precision is low, you'll see that each individual arrow is not really close to the target. So now let's put that to use by looking at some sample data. So this is the data of an experiment where students were asked to find the density of sucrose. And the right answer for the density of sucrose is 1.59 grams per centimeter cubed. So then you look at student A, and notice that each student did these experiments 3 times, so we can describe the precision of them. So we have student A, student B, and student C. So let's try to answer this question. What student or which student was most accurate? So remember accurate, how close they come to the actual value. The answer is 1.59. Which student came close to the actual answer of 1.59? And that's why it's really helpful to look at the averages here. So here are the averages. Which student came close to 1.59? You're right, it's student A. Right, student A, their average was 1.57. That's really close to the actual value. Now let's look at precision. Precision is how close a series of measurements come to each other. So you look at student A and student B and student C. The other way to think about this is which student was the most consistent, right? So who, when they took the density, got almost the same answer every time? Which student do you think? Yeah, right? It's student C. Look at the data there. Right? Student C, their data was very close to each other. Notice that they were probably the least accurate. So sometimes that happens. So what that probably means, the way that the student was doing the lab, was that there was something wrong with the setup or the equipment, because it seems like the student was making the same mistake every single time. That's the only way that you can be off by the same amount in the same direction every single time. Now, the next 2 questions ask you for the definition of error and the definition of percent error. So we haven't even learned what percent error is yet, but look back at this data and you can see the error is given. And looking at the numbers, can you figure out where those numbers came from? Like, how did we get the number 0.11? Can you figure it out? Right? It's the difference between the actual density and that student's answer. So let's write that down. Error is the difference between the experimental value and the actual value. And so what do I mean by the experimental value? Experimental value just means what you got. So this is what you got. And the actual value is the right answer, right? A, actual value, the right answer. You would subtract those 2, and so error can be positive or negative, but percent error is much more important than the error. Let's say I was trying to guess the mass of an elephant, right? And I was off by 5 pounds. Wouldn't you be like, oh my God, that's amazing. You did a really great job of guessing the mass of that elephant. But then if I was to guess the mass of something much smaller, a pen or pencil, and I was off by 5 pounds, you'd be like, that's kind of ridiculous. It only weighs half a pound. So in order to really get how close your answer was to the right answer, we need to compare it in terms of a percent. Were you 5% off or were you 500% off? So percent error is going to be the absolute value of the experimental value minus the actual value, or the absolute value of the error divided by the actual value. And then of course, because it is a percentage, it's going to be multiplied by 100%. And we remember that the absolute value means whatever the answer to experimental minus actual is, we're going to disregard the negative sign and we're just going to make it positive, because absolute value means the distance from 0. So let's put this into practice here. The density of copper is 8.92 grams per centimeters cubed. During the lab, you calculate the density to be 8.66. What is your percent error? Remember, when we do math problems, right, we're going to write the formula, then we're going to plug in the numbers, then we're going to solve for our answer. And we're going to circle the do and underline the clue. Question's asking me to find the percent error. And here are the two clues, the two numbers in this. It says the density of copper is. So this is my actual value. You calculate, so this is my experimental value. So my formula for percent error is the absolute value of the experimental value minus the actual value over the actual value times 100%. Always remember that the actual value comes twice in a row. That's how I remember, which one goes on the bottom. So the experimental value is 8.66 grams per centimeter cubed minus 8.92 grams per centimeter cubed divided by 8.92 grams per centimeter cubed. And then once I get that decimal, I'm going to multiply it by 100% in order to get the percent error. So when I do that out, this comes out to be 0.26 divided by 8.92, right? You would do what's inside the absolute value symbols first. And then doing the calculation, I get 2.9%. That's the percent error.